السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. أرحب فيكم بالجزء العاشر من مناقشة هيكلة اختبار الفيزياء للصف الحادي عشر متقدم، فصل الدراسة الأول 2023-2024 حسب هيكلة مؤسسة الإمارات للتعليم. وصلنا إلى الهدف الثامن عشر. هذا الهدف اقترحت المؤسسة 11 سؤال مختلف، سبحان الله، لتحقيق هذا الهدف، وهو يتعلق بدراسة حركة جسم بتسارع ثابت constant acceleration، وتحديد الاتجاه وتحديد البوزيشن والفيلوسيتي وأشياء مختلفة في حركة جسم بيتحرك بconstant acceleration. السؤال الأول: as an airplane. أظن هذا الفيديو راح يطلع طويل شوي، وهدف واحد إن شاء الله يكون هو قبل الأخير، والأخير راح يكون الجزء الحادي عشر. as an airplane rolls down a runway to reach takeoff speed, it's accelerated by its engine on one particular flight. One of the authors of this book measured the acceleration produced by the plane's jet engine, and the figure shows the measurement. What is the airplane takeoff velocity after 18.4 seconds? How far down the runway has the plane moved by the takeoff? الآن في عندنا شغلتين مطلوبات في السؤال: الاكسلريشن، الفيلوسيتي، والديستانس. تيك اوف فيلوسيتي يعني في فاينل، على اساس انه في انيشال زيرو، الطيارة في البداية كانت واقفة، بده الفي فاينل. وهاو فار يعني بده هاو فار يعني دلتا اكس. طبعا اللي بتطلع بالسؤال تقريبا هذا اكسلريشن والتايم، لازم ننتبه دائما الفيرتيكال اكسس. اكسلريشن والتايم تقريبا كأنه كونستانت، تقريبا عند قيمة هون 4.2/10، 4.3/10. أنا راح أخذها مثل الكتاب ما اقترحها 4.3/10. فإذا وهي كونستانت، لاحظوا كيف كأنها كونستانت. فال A is constant بتساوي 4.3 متر بير سكند سكوير. هذا as per the graph، حسب الجراف. لأن V final equals V initial plus A times T. V initial 0، acceleration 4.3، والتايم اللي عندنا 18.4. super easy. 4.3 multiplied by 18.4 it is 79.12 meter per second. If we need it as three significant figures, 79.1 meter per second. Now for delta x equals V initial T plus 1/2 AT squared, V initial 0, T 18.4 plus 1/2, the acceleration is 4.3 and the time is 18.4, but we must square it as the equation. The first term will be cancelled since the initial velocity is 0. Then the delta x approximately 728 meters. And that's it for this question. Second question, example 2.4, top fuel racing. Accelerating from rest, so V initial is 0 because of the rest. A top fuel race car can reach 148.9 meter per second. This is V final. Record established in 2003. At the end of quarter mile it is the distance. A quarter mile it is 402.3 meter. So this is delta x. For this example, we assume constant acceleration. What is the value of the race car's constant acceleration? We need the acceleration. How much is the acceleration? You must put the equation of motion V final equals V initial plus AT, V final squared equals V initial squared plus 2A delta x. Delta x equals V initial t plus 1/2 A t squared, and delta x equals V initial plus V final over 2, which is the average velocity during constant acceleration, times t. You should take this equation as your weapon in any motion question. What is the value of the race constant acceleration? The acceleration is at equation 1 and 2 and 3. Okay, so we may use one of them. If you need to find, you need V final for the first equation. You need V final, you have V final. V initial, you have it, but you don't have the time, so acceleration couldn't be delivered by this. The second one, V final, you have it, V initial, you need the acceleration, you have delta x, so you can use this equation. So put V final squared equals V initial squared plus 2A delta x. V final, it is 148.9. V initial 0, 2, acceleration is unknown, delta x is 402.3. Then you can find the acceleration easily by this equation. It is 27.6 meter per second square. How long does it take the car to reach this to complete a quarter mile run from starting? I need the time. So you can use the first one or the third one. I will use the third one. You can use the first one since you have the acceleration, or the third one. So delta x equals V initial t plus 1/2 A t squared. Delta x is 402.3. V initial 0 times t plus 1/2. The acceleration is 27.6 t squared. Solve this equation to find t. Or you can use the first one, V final equals V initial plus AT. V final, it is 148.9. V initial 0. You have the acceleration from the previous one, so 27.6 times t, and you can have t from here. So if you use the first one or the second one, you will have the time as 5.40 seconds. Solved problem. Racing with head start. Sultan has a new Dodge Charger with Hemi engine, good for him, and had challenged Khalid Miskin, who owns a tuned Volkswagen GTI, to race at local track. Khalid knows that Sultan Charger is rated to go from 0 to 100 km per hour in 5.3 seconds, whereas his Volkswagen needs 7 seconds to do the same job. Khalid asks for a head start and Sultan agrees to give him exactly 1 second. Before we continue with the problems, let us specify the specification of the cars. So the specification of the two cars V initial equals 0, V final equals 100 kilometer per hour. We should express as meter per second. So 100 kilometer, it is 1000 meter, and the hour is 3600 seconds. So it becomes like 250 over 9 meter per second. Now the acceleration for Sultan's car AS delta V by delta T, 250 over 9 minus 0, and the time for Sultan is 5.3 seconds. So the acceleration of Sultan's car is almost 5.24 meter per second squared. For Khalid, delta V by delta T, the same delta V, 250 over 9 minus 0, but the time for Khalid is 7, so his acceleration is 3.97 meter per second squared. Now let's go into the problems. How far down the track is Khalid before Sultan gets to start the race? We know that the time for Khalid before Sultan starts the race is 1 second. So this is the time needed for him to travel that distance. So A we can use this equation, delta x equals V initial t plus 1/2 a t squared. Now take in consideration V initial is 0 and the time for Khalid before Sultan is 1 second, and put it in this equation. V initial 0, the time is 1 plus 1/2. The acceleration for Khalid is 3.97 and the time is 1 squared. So this distance is only 1.98 meters. So it's nothing for the race. Now, at what time does Sultan catch Khalid? The idea to solve this question, Sultan catches Khalid, means that the position of Sultan equals the position of Khalid. That's it. So write this equation. The position of Khalid or Sultan, the final position is the initial position plus V initial t plus 1/2 a t squared. Now x Sultan xi plus V initial t plus 1/2 a t squared for Sultan should be equal to the position of Khalid x initial plus V initial t plus 1/2 a t squared. This expression for Khalid. Now we will suppose that the initial position for both is 0, so we can put here 0, and the initial velocity for both of them is 0 since it's a race. Now we are left with this situation: 1/2 acceleration of Sultan, time of Sultan squared should be equal to 1/2 acceleration for Khalid, time for Khalid squared. Now you can cancel the 1/2 with the 1/2. You have acceleration for Sultan and Khalid, but the thing is to deliver an equation between T Khalid and T Sultan. T Khalid equals T Sultan plus 1 second. Since Khalid is ahead by 1 second, then the time for Khalid is larger than the time of Sultan by 1 second. So put this in the equation. A Sultan T Sultan squared equals acceleration for Khalid. Time of Khalid is time of Sultan plus 1 square. Take the square root, then square root acceleration for Sultan, time of Sultan equals square root acceleration for Khalid, time of Sultan plus 1. Now you can substitute for acceleration for Sultan. It is 5.24 time of Sultan. Acceleration of Khalid is a 3.97 time of Sultan plus 1. And we can solve this equation easily and find time for Sultan, which is 6.72 seconds, and the time of Khalid, it is the time of Sultan plus 1, so it is 7.72 seconds. Now the question is, at what time? This is the time. How far away from the start are they when this happens? Now we want to find the position. Go back to the equation of position for either Sultan or Khalid and substitute. X of Sultan, x0 of Sultan plus V initial for Sultan, T of Sultan plus 1/2 acceleration for Sultan, T of Sultan squared. We assume that x0 is 0 and the V initial is 0 as well. Then 1/2 acceleration for Sultan, it is 5.24, and the time for Sultan is 6.72 squared, and the answer would be 118 meters. Try to redo this question by yourself. 2.440. A car is traveling west at V 22. This is V, and it is V initial. It is to the west, so negative. After 10 seconds t, the velocity is 17 meters per second in the same direction. So this is V final and in the same direction, so it is negative. Find the magnitude and the direction of the average acceleration. Now the average acceleration is delta Vx by delta t. We use Vx because it is in the horizontal position on the x-axis. Now V final minus V initial over time interval. V final, it is minus 17 minus initial 22 with a minus sign, and the time interval is 10. Minus 17 plus 22, it is 5 over 10, so it is 0.5 meter per second square. Since it is positive, so it is to the east. Question 54. How much time, the time is missing, does it take for a car to accelerate from standing start? Standing start means V initial equals 0 to 22.2, this is V final. If the acceleration is constant and the car covers 243 meters, this is delta x, during the acceleration. For such question, put the four equations for motion with constant acceleration and discuss this question to find these equations to find the equation with the only one unknown. First, t, it is unknown. Here and here and here it is unknown. V initial, it is known. Then V final, we have V final. And we have delta x. The equation that is suitable for this question is the last one, because it has only one unknown, which is t, which I am looking for. So delta x equals 1/2 V initial plus V final times t. Delta x 243, 1/2, V initial 0, V final 22.2, the time. Solve for this equation. T equals 21.9 seconds, and it is very super easy question. 26. A runner of mass, what we should do with the mass, okay. 57.5 starts from rest, V initial equals 0, and accelerates with a constant acceleration of 1.25. This is the acceleration until he reaches a velocity of, this is the V final. He then continues running with this constant velocity. How far has he run after 59.7 seconds? Here we have a trick, because V final may be reached before 59.7. So I want to check when he comes for V final. Start with the first equation. V final equals V initial plus A times T. V final, it is 6.3 equals V initial 0, the acceleration is 1.25 times T. Then T equals 5.054 seconds. Now the total time is 59.7, so he accelerates only for 5.4 seconds. What about the remaining time? This is T1. T2 should be equals T total minus T1. The T total is 59.7 minus the first duration is 4.04. So the time interval is only 54.66 seconds with constant velocity. So I have two delta x. Delta x with constant acceleration, it is V initial t plus 1/2 a t squared, or V final squared equals V initial squared plus 2a delta x, or delta x equals 1/2 V initial plus V final times t. One of these will be good. I will take the third one because I have V initial and V final and t. So the first delta x, let be delta x1, 1/2 V initial plus V final times t. 1/2 V initial 0, V final it is 6.3, and the time interval for that is 5.04. 0.5 times 6.3 times 5.04, which is 15.876 meters. Still, you can use V final squared equals V initial squared plus 2a delta x. You will get the same answer. Now delta x2 for motion with constant velocity, V initial t plus 1/2 a t squared. The acceleration due to this is 0 because it's constant velocity, and V initial it is the V final for the previous interval. Or you can use the same equation, delta x equal 1/2 V initial plus V final times t. But put in your consideration that the V initial equals the V final because the motion is with constant velocity after all. So it's very easy to use this one, V initial 6.3 plus 6.3 times the time interval with constant velocity, it is 54.66, which we get before. So the answer is so it is 344.358 meters. Now the total distance is delta x1 plus delta x2. The first one is 15.876 plus the second one 344.358, and the answer should be almost 360 meters. It's very easy to solve this question if you use these two equations. Don't go into other equation for this question. Why? Because I know V final and V initial and the time for every piece of the motion. What is the velocity of the runner at this point? It's constant. It's 6.3. What is this question? What is the velocity of the runner at this point? You told me in the question. Until he reaches a velocity of, and he continues with this constant velocity. What is this? Okay. A fighter jet lands on a deck of an aircraft carrier. It touches down with a speed of 70.4. This is the V initial, and comes to a complete stop comes to a complete stop, so V final is 0 over a distance of, this is delta x. If this process happens with constant acceleration, what is the speed of the jet? 44.2 meter before its final stopping. This is another delta x. So what is this situation here? The situation is V final will be considered to be unknown because he is asking about it. This is the final stop with this delta x. I need a final stop without a final velocity without stopping now, but with other distance. Why he gave me such information? The first information is to find the acceleration with the full stop for complete stop. We can use V final squared equals V initial squared plus 2a delta x just to find the acceleration for the aircraft. So 0, V initial is 70.4 squared plus 2, the acceleration with the total distance needed to stop the aircraft. So the acceleration is 12.554 minus sign meter per second square. So this is the acceleration for the aircraft or airjet. Now I need to find V final. Before full stop in motion, I will use the same equation, but delta x now it is 197.4 minus the last 44.2 meters. I need the velocity before complete stop by 44.2 meters. So the distance will be covered in this time interval is 197.4 minus 44.2. It is 153.2 meters. V0 it is 70.4. 2 acceleration minus 12.4, and this is the distance. So the answer will be 33.3 meters per second. 58. A bullet is fired through a board of 10 centimeter thick with a line of motion perpendicular to the face of the board. If the bullet enters with the speed of, this is V initial, and emerge with, this is the V final, this is the emerging velocity, what is its acceleration due passing the board? This is delta x. It's easy to use the same equation before. V final squared equals V initial squared plus 2a delta x. So a should be V final squared minus V initial squared over 2 delta x. Substitute and get your answer. 200 squared minus 400 squared, 2 times 10. And the answer is 600,000 meter per second square. This is in meter. 10 centimeter, it is 10 to the minus 2 meter. I'll stop here and I will continue in the next video with this question or this goal and 19 and 20. Inshallah, next video will be the last one.